document and email session today. We are going to see why Teradata is evolving in the data warehousing area today. And once we discuss why Teradata and what is the importance of Teradata in the warehousing technologies, we are going to see what are the course topics we are going to see in the rest of 30 to 40 classes. And then I will show you the documents, what we are going to show, and the case study introduction. And I will explain you the plan of execution of this training, from which date we are starting it and what is the timings and the fee structure. Everything we'll discuss here, and I will open the lines for the question. So before start, let me see if you have any questions. Lavanya? Hi, Lavanya. Okay, if you have any questions, let me start with. So why Teradata? Nowadays, Teradata is being used by many of the organizations for implementing their data warehousing analytics. Right? So to understand what is the business problem and why and how the Teradata has solved that problem, let us take a multinational bank. We know the bank business, right? It will lend money and take some interest, and when we do the fixed deposits, they would give some interest, and the difference between these interest rates would get the benefits to the bank. So that is the core banking business of any of the organization, right? So here let us consider a bank of having 10,000 branches across the globe. It is a multinational bank, so it has operations and services across the globe. So let us take a bank of having 10,000 branches, and let us suppose each branch has 1 lakh customers, right? So we are considering a bank of having 10,000 branches, and each branch has 1 lakh customers, and how many transactions per day a customer would do in general. Okay, so bank has so many products: savings accounts, fixed accounts, credit cards, loans. All such products are sold by the bank and serviced by the bank. If I consider all these products, okay, the share brokering, the direct accounts, all those, can I consider each customer can do 2 transactions per day? Yeah. So if I consider each customer can do 2 transactions per day, what could be the total number of transactions per day for the whole bank? It is a simple calculation that 10,000 branches multiplied by 1 lakh customers each multiplied by 2 transactions per day, right? It's nothing but 2 billion transactions. So each bank has 2 billion transactions per day. So when we have 2 billion transactions, how many data records are impacted at the back end of the bank's database? Right? Minimum of 2 billion, and it could be more than 2 billion also, right? Because some transactions may be impacting more than 1 data record. For example, if you consider fund transfer, the fund transfer transaction has to impact 2 records minimum, right? One is the account from which you are deducting the amount, and the other is the account which is being credited with the amount. So these 2 accounts has to be updated with the proper amount. So 2 records are impacted with a single transaction. So if you consider those transactions also, minimum of 2 billion data records are impacted per each day with all these transactions. So to maintain these transactions and to store these transactions and to report these transactions, we have to have very sophisticated RDBMS, isn't it? So let us consider RDBMS. Okay, we know there are so many RDBMS available in industry. Those are Oracle, DB2, SQL Server, all these databases we generally use for all our database related operations. Okay. So when we have this, let's consider the database which is having a processor capacity of 2 gigahertz and it has a capacity of storing some huge amount of data. Okay, let us suppose right now we have only 1000 records. Okay. We have 2 gigahertz processor processing 1000 records, and let us consider it is taking 10 seconds of the time. Okay. So with this, data size will remain constant every day? No, it may increase, right? So based on the business, every day by day the number of records may increase. So yes, here also the number of records could increase, right? So when the number of records are like this, 10,000 records, would this time remain constant, or would it increase, decrease, or remain constant? Okay. As the processor speed is constant, we cannot increase it day by day, but the number of data records got increased, the processing time would increase, obviously, isn't it? In the same proportion, how the data is increased, in the same way the processing time would also increase to 100 seconds now. Okay, after 2 more months the data could be like this, then the processing time would like this, 1000 seconds. So what does it mean that the processing time increase? When I say processing time increase, that means the transactions which used to complete by 10 seconds earlier, now the same transaction is taking 1000 seconds. For example, if you consider the same fund transfer transaction, when you join the bank, you used to do a fund transfer transaction within 10 seconds earlier. Now, if it is taking 1000 seconds, do you have that much patience to wait the transaction to complete? Or during this time the sessions will also fail, right? Because we generally use the web applications, right? So this is a MNC bank, a online portal through which we generally do our account transactions, right? So all these left side operations we can do through online. So if you see, fund transfer is also one of the transactions there. So when you join the bank initially, you were able to complete fund transfer within 10 seconds, but now if you do the same fund transfer after 1 year, if it is taking 1000 seconds, the sessions may expire and it may take a long time to complete the transaction. So will you be a satisfied customer for that bank anymore? No, you cannot be a satisfied customer. We see for any other bank which can give a better service within less time, isn't it? So if all the customers look for other banks, other competitor banks, what happens to this organization? It will get into losses, right? The revenue loss. So revenue loss is the biggest impact for any organization. So for this bank, which we consider as a sample, would also get a revenue loss if they don't take any solution here to decrease the performance time and to decrease the processing time. So what is the solution here? As this is the transactional system, there is online transactional processing system. Yeah, they come up with a solution called archiving the older data. Okay. So here, why we are keeping this much of used data? Are we really using it? No. If you consider any of the reports, for example, if you want to see the recent 1 month transactions or 6 months transactions, you go to ATM or you go to online portal and you will download the document, right? You download the transaction reports. But do you ever look for data which is beyond 2 years, 3 years for the bank transactions? No, generally no, right? We don't look beyond the data which is more than 1 year old or 2 years old in general. So why we are keeping all this data which is not necessary by many of the customers? Yeah, that was the question arised when they get into performance issues and when they do the brainstorming to see how to resolve it. They found there is a lot of unused data in the systems. So we will archive the older data and we'll keep it in separate machine so that here we ensure it has always sufficient number of records which can be processed within 10 seconds. Okay. So what happened to the old data? They have archived it and they have kept it in another system called analytical systems. You can see here. They have come up with one more system called analytical system, and this analytical system is also a database. So this also has a processor and a disk memory, but it is a good high configuration machine than the OLTP. But this is confined for a number of records only and confined for a period of data only. But here it is a historical processing of the data, so it could be more sophisticated machine. Then we have 4 gigahertz of processor, and we may have a lot of size, a lot of GBs or TBs of data to store. And for example, here if it has 10,000 records, the processor of 4 gigahertz can process it within 10 seconds. Let's assume. Then, how about the data growth here? Here also the data growth is very high, right? Because these type of OLTP systems would every day send data to this OLTP machine, which is 6 months older, for example. Okay, we have taken a threshold of 6 months of period. Whatever data becomes 6 months older here, the data would come here, right? So if it comes here, what is the time taken to process it? It would take 10 seconds to process the data, for example. And would this data remain constant? No, every day it is also getting data from the transaction system. The rate may increase like this. So the processing time would also increase like this. Okay, so whatever reports, whatever analytics generally have been done on the OLTP system, okay, whatever analytics has to be done, it could take 100 seconds now. Okay. How about after 1 year? The data may increase like this. Then the same analytical report would take 1,000 seconds. Okay. So what does it mean by increasing the processing time in OLTP for 1,000 seconds? What's the impact to the organization? Okay. Generally, this system is being used by the top management of the organizations, right? So when we have the top management of the organizations doing this all analytics, we have to ensure they would get the analytical reports within very less time, isn't it? So all CEOs, CFOs, CTOs would get this analytical report observed. So shall we wait? Shall we ask them to wait for these many number of seconds for the same report which they used to get within 10 seconds? No, right? So we have to have a solution here. So in early 1980s, when every organization has implemented analytical systems, for first 1 year, 2 year, they are okay. They are happy with the systems and performance. But once they start getting a huge data, all would get into performance issues, right? So in early 1980s, Teradata has come up with a solution, right? So let us see what is the solution that Teradata has come up with. Yeah, this is the normal machine, the legacy machines, Oracle DB2 SQL Server machines. Okay. So let us consider 4 gigahertz machine and 1,000 records, which would be processed within 10 seconds. Now, how Teradata would improve the performance? Yeah, let us take this. We have a processor of 4 gigahertz, and we have a disk memory, which consists of 1,000 records. And here the processor would start behave as multiple virtual processor because of a patented software of Teradata called Parallel Database Extension. So there is a software which is patented by Teradata Corporation called PDE, Parallel Database Extension. So by installing the PDE, the hardware processors start behaving as multiple processors, and these multiple processors are not the hardware components of the processors, but they are the software components of the processors. And in a similar way, the hard disk, would also start behaving as multiple disks. Okay? These are also called as the virtual disks, right? So they are not the hardware component, the actual hardware components, but they are the software simulations of the hardware components. Okay? So when you have 1,000 records to be inserted in the system, these 1,000 records would have to be distributed across all the available virtual disks like this. Okay? 350 records, 300 records, 350 records. And you have this 350, 300 and 350 records. How the records would be processed? These records would be processed in such a way that each processor has a relation on its own associated virtual disk. See here the association. It means each virtual processor has a communication channel for its own associated virtual disk. What does it mean by a dedicated association? That means this virtual processor 1 can access data in the first virtual disk only, but not in any of the other virtual disks. And this virtual processor can process data in its own associated virtual disk without depending on any of the other virtual processors. Okay? So it cannot process data of any other virtual disk, and it no need to dependent on any of the other virtual processor to process data in its own associated virtual disk. So this mechanism of the architecture is called shared nothing architecture. Okay? It is called as shared nothing architecture, as it is not sharing anything from any of the other virtual disks, and it is not dependent on any of the other virtual processors. Okay? So now, what is the time taken to process these 1,000 records with this Teradata machine of 3 virtual processors and 3 virtual disks? So let us calculate it. The virtual processors are having same capability of the hardware processor, isn't it? We have a 4 GHz machine. All virtual processors which are simulating the hardware processor are also of 4 GHz, and here we have seen the 4 GHz machine takes 10 seconds of time to process 1,000 records. Now here in the first virtual disk it has only 350 records. How much time this virtual processor would take? Right? If you have 1,000 records, it takes 10 seconds, but now here it is 350 records. So how much time it has to take? The simple calculation, 3.5 seconds, right? 1,000 records processed within 10 seconds, 350 records will be processed in 3.5 seconds. Similar way, when second virtual disk has 300 records, how many minutes or how many seconds this processor would take? It would take 3 seconds. And how about third virtual disk? If it has 350 records, how many seconds this third virtual processor would take? Again 3.5 seconds. So what is the time we need to wait to generate report out of these 1,000 records now? All these virtual processors are running parallelly on their associated virtual disk to process the data. So what is the time taken to process the whole 1,000 records here in the parallel processing? Can you tell me, is it maximum of all these timings, or minimum of all these timings, or the sum of all the timings? Because all these are processing parallelly on their corresponding virtual disk, right? So it is the maximum of the timings what we have to wait for. Even though the second virtual processor completed its processing within 3 seconds, but still it has to wait for other processors to complete their amount of data. So yes, the second processor also has to wait for completion of all these virtual processor to process the data. So the maximum time we need to wait to get the report generated out of Teradata machine for 1,000 records is 3.5 seconds. Okay. So earlier with the legacy machines, we had to wait for 10 seconds to get the same report out of 1,000 records, but here due to the virtual mechanism, we can process the data within 3.5 seconds. So how much optimization we got here? Okay, the processing time decreases from 10 seconds to 3.5 seconds. So can I say almost 60% of the optimization we got it? right? So here, when you compare the performance, here it has one set of processor and disk memory, and here it has 3 sets of processors and disk memories. So in general terms, you can say it is 3 times better than the normal machine, isn't it? Right? So it is 3 times better when it has 3 virtual processors and 3 virtual disks. It is 3 times better than the legacy machines. The Teradata machine is almost 3 times better than the normal machine. And with this machine, how many years we can be happy? We can be happy up to 3 times more than what we can be happy with this normal traditional machine. For example, with this traditional machine, we are happy for 1 year, but a machine which is having 3 virtual processor and 3 disks which are running parallelly, which is 3 times better than the normal machine, how many years we can be happy? Almost 3 years. But let us consider the data distribution constraint, which is not almost always. So let us consider only 2.5 years. Okay. With the traditional machine, if you are happy for 1 year, the Teradata machine can be happy for almost 2.5 years. Okay. So what happens after 2.5 years? Do I need to hit into performance issues? Yes, obviously, because the system is limited always. Once you configure it, because of the virtual processor and virtual concepts, yes, it is giving you the performance, but as it is limited, it is up to 2.5 years only, right? With the traditional machines, it is only 1 year, but now we increase it to 2.5 years, but after 2.5 years, this also saturated. So what to do? Even with the Teradata machine, after 2.5 years, I'm not going to get good performance because of the huge data volumes. Then what shall I do after 2.5 years? So when you hit into performance issues, you can again approach the Teradata Corporation and you can purchase one more system which can be plugged in to the existing machine. See here, you can purchase one more machine and you can plug in to the existing machine. And this plug-in would happen both at processor end and the disk memory. So when you have the 2 machines connected, and when you restart this machine, your configuration now has 6 virtual disks and 6 virtual processors, and the same 1000 records now has to be distributed across 6 virtual disks, right? So the distribution could happen like this: 150 records here, 200 here, 150 records here, and 150, 200, 150 here. So across 6 virtual disks, all the 1000 records got distributed. So now, what is the time taken to process 1000 records out of a Teradata machine of 6 virtual processors and 6 virtual disks? Let's calculate. So how much time the first virtual processor would take to process 150 records which are associated in its first virtual disk? This 1.5 seconds. Yeah, it is all simple calculation. 1000 records processed in 10 seconds, 200 records processed in 2 seconds, 150 records in 1.5 seconds. Similarly, here 1.5, 200 records 2 seconds, 150 records 1.5 seconds. So now, what is the time I need to wait here with the Teradata machine of 6 virtual processors and 6 virtual disks to generate a report out of 1000 records? Can you tell me? Is it 1.5 seconds or 2 seconds or sum of all these timings? Here, even though this process complete within 1.5 seconds, it has to wait for other processes also to complete, right? So maximum of 2 seconds I need to wait to generate report out of this machine for all the 1000 records. So it is now 2 seconds. After upgradation, within 2 seconds I am able to complete. Earlier it was 3.5 seconds. Now it is 2 seconds. So how much optimization I got? In general terms, one system has become 2 systems, double the system, right? So the performance was also almost double. So with the normal machine, if you are happy for 2.5 years, okay, with the single Teradata node, the single Teradata machine, if you are happy for 2.5 years, with the double the performance of the node, how many years you will be happy? it is double the time. But as per the constraint of the data distribution, which is not 100% even, let me consider at least 4.5 years you will be happy with this machine, right? So with the double the performance of the system, you would get your systems working 4.5 years very much happy, right? So this is how Teradata has made solutions in the OLTP industry, that you can process the data within very less time with all these virtual concepts, and you can combine the machines and you can get the benefit even after certain years when the system getting the performance issues. This is called as the scalability. The first characteristic is called as the unconditional parallelism. Because of all these virtual processors, it will get the unconditional parallelism, and it is the scalability, where you can increase the resources of the system without decreasing the performance of the machine. This is called as scalability. Okay. So with these two characteristics, Teradata has come up in the industry, and all the data warehousing projects are getting moved to Teradata nowadays. So that's where we are here to learn Teradata and to get good opportunities in the market. Okay. And these are the topics what we generally cover in our development and DBA tracks. Okay. So I'll just give a walkthrough. So here we discuss about the Teradata architecture. What are the different components of the architecture we have, and what is the data distribution, what is the importance of data distribution, and what are the primary index and data production. As we have so many components here, there may be a possibility of failure of any of the component at any time, because there are so many processors, so many disks here, right? So the rate of failure could be more. So they have come up with a fault tolerance technique at each individual component level. Even though one of the component failed, how you can still run the system. Okay, so they have come up with all the fault tolerance techniques, the terms called cliques, clusters, raids, logs, journals. So we'll discuss all those concepts here in data production, and then the spaces and tables, the terminology of spaces and tables, and then the SQL. Then we will start the SQL, the comparison of ANSI to Teradata. What are the differences? What are the new features added in Teradata in the SQL? What are the extensions of the Teradata SQL? The advanced SQL of OLAP we'll discuss here. And then the tools and utilities like SQL Assistant, VTech, Fast Load, Fast Export, Multi-Load, and ATPT. And once we complete all these utilities, we have a case study which we can implement by using all our data warehousing knowledge, ETL processing, and the Teradata utilities. Okay. And we have the explain plan and statistics for the performance tuning techniques. Okay. And coming to the DBA, we have the similar sessions for the first 15 days, the architecture, data distribution, data production, and advanced SQL. And after that, we generally start all the admin utilities like Teradata DBA basics, how to manage the users and accounts, and the data dictionary, okay, and the capacity management and planning, how we can forecast the space and capacity details, and how we can act upon it, okay, and how to manage the access rights, okay, how we can efficiently manage the accesses and user properties with the roles and profiles concept, and the security management, okay, and workload management, the TASM, the Teradata active system management, okay, we go through, and then access logging and query logging. We will discuss about DBQL logging and access log here, okay, how we can set up some events so that it will capture any transaction that would require analysis by the DBS later. And then here it is performance monitor and the archival, restore, and copy. How we generally archive the databases, data, tables, and whenever it is requested to restore after accidental transactions on the tables, okay, we can restore them and we can copy them to the other systems. And there is a cutting edge technology involved in Teradata, that is Viewpoint. Viewpoint is a Java-based web portal through which we can monitor all the Teradata servers in the organizations. We can see their performance. If they are hit into any issues, we can resolve them with the Viewpoint. Okay. and performance tuning. We explain plan statistics, joint strategies, and the other indexes and techniques. Okay. Multi-set, UPI, NUPI, the combinations, every performance related discussion we made here. Okay. And how this program will be executed. The regular classes are going to be start from 12th June onwards at 8 AM IST. The first 12 classes are common for both developers and DBAs, and after this we have a split in the batches. The DBA would start at 7 to 8 AM IST and development would start at 8 AM IST. So the total period to complete both the development and DBA would be 30 days, around 30 to 35 days in middle. And the course structure, fee structure for both the courses is 15K each, and if you join both together, then you will get a 5K discount and you can pay only 25K for both the tracks to complete the single batch. So these are the course structure and fee structure. Any questions, anyone? You can unmute yourself, or you can use the chat window in case your mic is not yet set up. If you have any questions, you can discuss. Okay, very good. Thank you. If you need any information, you can be in touch with our team. They will respond to you with our all questions and clarifications. And I hope you all see on 12th June, where we are starting the regular sessions. Now, if you miss any session, you can request for a recording. In the entire 30 to 35 sessions, you can request for 4 to 5 sessions as a recording in case if you have any unavoidable situation and you're not able to attend the class. You can send an email so that our team would record for you and send it to you so that you can catch it up before coming for the next session. Clear? Okay, good. Any other questions? Okay, fine then. Thank you very much. Hope you all see you on 12th June at 8 AM IST. Our team would be in touch with you. You can complete your enrollments and attend the trainings. Thank you. See you all. Bye.